So this time we're going to compute some summary statistics like mean and median and things like that. And so there's so here's the home sales in Cincinnati, Ohio suburb, and this is again example from your book. We have 12 homes here. Here are the selling prices, and using this we're going to talk about some different summary statistics measures. Okay. Since you guys have, this is real basic stuff that you guys learned in maybe the first couple of weeks of Math 117, I would assume. So we're going to go through this very quickly. In Excel, just to make sure that you guys know how to compute this or in Excel. So this is the average. So mean, right? Use the average function. Median, use the median function. Min, the smallest number, right? So min, max, that's that. Also, it might be useful to maybe sort this also. So let's try sorting this. So just click anywhere in the click any selling price. We're going to do the right click and then sort and then do smallest to largest. Okay. So from this, so it's obvious that min is 108,000 and max is 456,250. Okay. Okay. Now these are pretty obvious. So one thing you might not remember is the range. Range is a difference between the largest number and the smallest number, right? So here you would have to go max, and then select the data, and then minus min. And then select the data again in the parentheses, B2 through B13. So that would give us the range. So that's the range. And the variance, variance is, now we start talking about the spread of the data. So here, spread. So mean and median, these are called the like the location of centers. So these are the centers of your data. Mean is the average, where you add up all the numbers and divide it by the count of the numbers. So here, if you add up all the numbers and then take the total and divide it by 12, that will give you the mean. Right? Now the median is the middle, right? So you guys see that. Median is the middle of the data. So the middle, and there's how many values here? 12, right? So there are 12 values here. So the middle would be, if you go 6, and so 1, 2, 3, 4, 5, 6. So this is a 6th one. And so this is 6th one. So middle will be right here. Do you remember how to get the median if you have even number of data? Yes.
Take the average between the two.
2, right. So take the average between the two. All right. So here we have, this one is the 6th one. And that one is the 7th one, so I could take 199,500, and then take the next one, 208,000, and then divide by 2. So that should give me the middle, median. Vary in the middle when the data are arranged in ascending order. Ascending means the lowest to highest. So if you have an odd number of observations, let's just say if you have 5 values. So if you have 5 values, so it's 1, 2, 3, 4, 5. So the middle value should be the 3rd, so you could say, okay, here's my median. Here we had 12 values, so there's even number of observations. So that's when you have to go, so that you know that the middle is between 6 and the 7. So we just have to just do the average of the two numbers, 6 and the 7. If I say average of these two numbers, then I should get the median, 203,750. And is this consistent with what we already have? Oh, there it is. Okay, good. Now variance, we have something here. So variance is, there's a formula here. There's a formula. So it's a little bit complicated, but it's good to look at it so that we make sure we understand what it is. And so this is saying, so we want to measure some deviation. And so how far the values are from the average. How far the values are from the average. So here what we're doing is we're going to take each value, xi, so each value minus the mean. So that will give us the distance between the value and the mean. And then now if you do this xi minus x bar, so if I take Okay, if I take this number and then minus the mean, that minus that, that's going to give me a negative value. Right? So 108,000 minus 219 something. So let me let's see. Is it safe to? Okay, let's try making it. So here, so let's say if I take 108,000 and then minus the mean, the dollar sign here. Okay, so take the individual value minus the mean, and then suppose I did it all the way through, then some numbers are negative, right? The small numbers result in the negative differences, and large numbers result in the positive values. So if I average these, what would I get? Let's see. If I average, let's say I just try summing. If I sum, all right, sum. If I sum these, then I got the negatives and then positive kind of canceling each other out. So I get, what's this? What? This means 0, right? And so I get a 0. So, and if I average, I still get the same thing. You know, sum is 0, 0 divided by 12, that's going to be 0. So it doesn't actually give us the spread. It doesn't give you any information. If you have negatives and positives, you're adding them together. So here we want to take the result, and then square the result, which means if you square the results, it'll turn the negative values into positive values, much larger values, but anyway, it'll be positive. So this is how we could square, one way. So parentheses, and then this is like a shift 6. So the number 6, shift, and then the number 6. That's all caret, that's for the power, and then 2, that gives me the squared value, and very large number, and then I take this, and now I got very, very large numbers, but they're all positive. Okay, so now if I sum that, I get a very large positive number. So this part is where you go x sub I minus the mean, and then you square, and then you sum. Okay, so that's what we just did. And then I take that, and then I can't take the average, but it's not quite the average. You divide by n minus 1. So it's instead of dividing by 12, you divide by 11. So one less than the count of the values, n minus 1. So I take that. So take this number, divide by, let's just say 11. Okay, 11. All right, that gives me, I don't know what it is. Okay, that gives me B. I take that and divide by 11. That gives me some number. So this is divide by n minus 1. Okay, so that gives me a variance. That gives me the variance, and you could see this over here. That's the variance. So then the formula is just a var.s. Okay, so which is a lot simpler than going through all this calculation. But I just want to show you so that we understand where it comes from. Now this one, I'm showing the decimal digits, and here I am not. So that's the difference. So maybe make it look the same by getting rid of the 2 decimal digits. So that's this one. So it's a very large number. But so what we do is because we squared before, that's why we gave up. We ended up with really large numbers. Now we canceled it out by taking the square root where it was over here, standard deviation. So variance is s squared. It's called s squared. You take the square root, then you get the standard deviation. So I take this, and then if I take SQRT is the square root function, so SQRT, this value, that gives me a standard deviation. So this, let me make this rounded a little bit. Okay, so that's our standard deviation, and that's what we get here by using this function. Okay, so if you kind of got lost in the details somewhere over here, don't worry about it because I never make you do that again. But you gotta just go straight to these Excel functions to do this kind of calculation. Okay, so here, this is how you type. So you say stdev.s, and then just take the numbers, and that gives you the standard deviation, which is again the same. 4. Okay. Okay, so this gives you the measure of the spread. This tells you the typical deviation from the average. So typical deviation from the average. So 95065. 95065. So if you have, so let's say, let's take a look at like this number. Let's say look at this number, 298000. Now we ask, okay, is this selling price kind of typical or is it much higher? So compared to the mean. So how does this compare to the mean? How does this compare to the mean? Okay, so let's say, how does 29 compare to the mean? Then we would say, okay, well, what is the difference between this and the mean? So difference is 298000 minus the mean, which is 219938. Okay, so going from here, so that gives us, and let me just do that calculation quick. And so that gives us 78,063. 78,063. So taking 200 that minus that gives us 78,063. Okay, so is this very different from the mean, or is it kind of pretty close to the mean? And then we compare this to the standard deviation. So standard deviation is 95065. So this is actually slightly smaller than the standard deviation. So we would say this is a typical value. So this is typical. It's close enough to the mean, so it's not like really expensive. So this is a typical price. It's not it's not that large compared to the mean. Okay, to the mean. So this is how we use the standard deviation. So standard deviation is your typical deviation. If you have a number that's within the standard deviation, so that it's pretty close. It's typical. It's not an outlier. It's not really large or really small. Now if I take this number, the largest number, so let's see what the difference is. 456250. Okay, so how about 4566250? Okay, what is the difference between this and the mean? 456250, and then minus the mean, 219938, and that's the difference. Okay, so how does this compare to the standard deviation? So 236,000 versus 95,000. No, much larger than the standard deviation. So we would say, okay, this is not close to mean at all. It's very far from the mean. Now, coefficient of variation is this gives you a measure of how spread out your data is. This is just the S, standard deviation, divided by the mean. So here we could see that here's the standard deviation, 95065 divided by the mean. So that gives you a, in terms of percent, is 43%, about 43%. So this says, so basically, if this is more than 100%, then your data is considered very spread out. There's a large spread. If the numbers go like all over the place, then you expect the coefficient variation to be larger. If the numbers are closer together, then you expect this to be smaller. Okay, so that's the coefficient of variation. The percentile. Percentile is, so this gives you an idea of the ranking of the number compared to other numbers. So if you took an SAT or some standard test like that, so if you took some standard test, and they might give you a percentile. So if you're told that your score was at 99th percentile, is it good or bad? Your score is at 99. Good. Yeah, it's good. That means you're at the top 1%. Your score is at the top 1%, so 99% were below you. So now if you are at the 50th percentile, what does that mean? That means you're right in the right in the middle. So 50% did better than you, 50% did worse than you. If you're at the 10th percentile, is that good or bad? And so only 10% of the people did worse than you. So basically, it tells you what percent were below the number, what percent were below your number. And so by definition, median is a 50th percentile, but it's right in the middle. Now, if you're asked to actually get the percentile, come up with a percentile, let's say 85th percentile, then what you could do is you could just use this function and say percentile. And notice that as soon as you start typing, say equal to and start typing the function, it gives you choices. So this is a really nice user-friendly program that it gives you choices. So now it's like taking a multiple choice test compared to like essay test. It gives you your multiple choices right here. So now you just have to pick. What is recommended is you should choose the EXC because that's your standard thing, deemed correct by the experts, mathematicians and statisticians. INC is a little bit kind of rough way. Whether you do EXC or INC, the values will be very close. Why not just do the standard one? So use the EXC, this one, and then you choose the data, okay, and then it says 85%, so just say 85%, just type in 85%, or you could type in 0.85, which either way is fine. So that will give you the 85th percentile. Okay, so that gives you 305,912, so about 300,000. So about 300,000 is at the 85th percentile. So you could say something like 85% of homes have price under 306,000, roughly. So home sales too. So this is here. What's the point of this example? It's the same data set, but now we want to talk about the z-score. Z-score. So that's a way. I was saying before to determine whether a number is far or close enough to the mean, we could compare the difference to the standard deviation. So here we're going to do it more formally. So z-score will tell you how far your number is compared to the standard deviation. Okay, so we need to have the mean and the standard deviation to calculate the z-scores. Now we're going to compute the z-scores. So what is a z-score? Here's a formula. You take the difference, each value, the value minus the mean, and then you divide by the standard deviation. So if the difference is close to standard deviation, then this value will be like around 1. Now if the distance is let's say twice the amount of the standard deviation, then this value will be equal to 2. So it tells you like how many standard deviations away from the mean this particular value is. There's a function called standardize. So this is one. So you could do this or you could do that either way. So you could actually type this in, let's say parentheses, the individual value minus the mean, and then you have standard deviation, or you could use standard. So you could do it either way. So let me just go to standardize. So standardize. Okay, and then it tells you what to do. X, that's the value you are working with, and then the mean, comma, and choose the mean. And then now after you choose the mean, remember what you need to do because we're going to copy this down. The dollar signs, right? So you put dollar signs in. So function key F4. So hopefully that works for you. If not, just put in the dollar signs yourself. Okay, so that's the mean. And then do the same thing with the standard deviation. So you click on the standard deviation, and then the dollar signs. So that's it. So this tells you how many standard deviations away from the mean this value is. So 138,000. How far is this from the 219,937? So how far? What is the distance? Okay. So it says here is negative 0.862. Why is it negative? this is less than the mean. So less than the mean, so it's left of mean, so it's going to be negative. So the smaller number minus the larger number. Okay, so this tells you, what does it say? It says my value is less than the mean, and then how much less? It's about 0.86 times standard deviation less. Okay, so this value is about 0.86 times the standard deviation below the mean. What about this one? How would you interpret this one? This value is 2.5 times standard deviation above mean, so that kind of tells you, oh, it's pretty far above mean. It's pretty large. Okay, so that's how you could interpret the z-score, and these numbers are used very frequently to compare. So how to quantify how large or how small it is compared to the other numbers in the data set. Now here we're going to talk about the quartiles and the outliers. So again, the same data set. And so outliers are the values that are far from the other values that are unusually large or unusually low, unusually large or unusually small. And one way that we identify the outlier is to look at the z-scores. So here's one definition of outlier. If the z-score is less than -3 or greater than +3, we would call it an outlier. So for example, if I were to go over here and ask, do we have any outliers here based on the z-score? Do we have any outliers? Gotta be greater than 3, bigger than 3, right? So here we will say based on the z-scores. On the z-scores, there are no outliers here. If you see any number that's greater than 3 or less than -3, then you will say that's an outlier. Okay, that's one way to identify outlier, but it's not it's like there's different definitions. So that's one definition, and the other definition is to use the quartiles. So let's talk about the quartiles. So quartiles is 25th percentile, 50th percentile, and the 75th percentile. So here is a 25th percentile. Okay, and here's a form. Instead of using percentile, you use the quartile function. So quartile.exe, and then feed it the data value, and then say 1. Okay, let me type this also. Using core, so I can talk about it as I type. .exe, okay, and then we select the numbers, okay, and then since I'm going to copy this down, I want to use 1, 2, and 3 for the quartiles. I'm going to put $signs here. Then I'm going to just reference the number 1, and if you put down a 1 here, that gives you the 25th percentile. That's called the lower quartile. And then now I could copy this down. So now the third one, that's the 75th percentile. Okay, so that's 25th, and then the 50th, which is same as the median, and the third is the 75th. Okay, so those are it says right here. Those are the quartiles, and you could use this to create box plots. So let me show you how to create this box plot. And I think it should, there it is. Okay, I showed you right here. So you select the cells, and then go to insert. Okay, so just follow this. So I'm going to go over to select these guys. This time I'm going to include a heading. So when you do a plot, usually good to include a heading. When you're doing functions, don't include a heading. Okay, so let's take that, and then I'm going to say insert. Then locate this thing that looks like a histogram. So insert, locate, and it says insert statistics chart. So that's what it's called, insert statistics chart. And ignore the histogram. These are bad histograms, so don't use this for a histogram. So ignore the histogram, go over to the box and whisker. For the box and whisker, and then click on that. So now you have a box plot. And you might say, well, this doesn't really look like the box plot you have over here because, well, this one is kind of standing up, and then that one is kind of lying down. Like this is like on the side, and this one's kind of going up and down. But it's the same thing, really. It is the same thing. And let's here down, box plot. Okay, so these are the prices. These are the prices. Okay, so again, this is just this is going left to the right, from left to right, and this one is going from bottom to the top. But it gives you the same information. Okay, so what does it say? This line over here in the box is a median. That indicates the median. So over here is a median. And the left one, or the bottom edge, is a lower quartile. On the top edge of the box, that's over here. That's the 75th percentile. So that's your upper quartile, Q3. Okay, and the interesting thing is it gives you the outlier. Usually like a little dot away over here. So that's the outlier. And that is this one. 456250. So the highest value here, it says it is an outlier. So you can see it gives you something different. It's a different information. So this one, it says there's an outlier. If you use a z-score, there is no outlier. So it depends on which definition you're using. So you have to clarify which one am I supposed to use, the z-score or the quartile.